All right, folks, we got section 11.10, Parametric Equations, page 2. So we have just two problems on this page. The example problem number 2 says, given the following system, complete the table of values for the parametric system, then plot the graph of the system. This will be easier to graph if you use decimal values in the table. So I'm going to approximate everything to the nearest 1/10. When you plot the graph of the system, draw arrows on the graph indicating the direction of the path as t increases. So we have x as a function of t, 1 plus 2 cosine t, and we have y as a function of t, y equals sine t, and we're going to look at values from 0 to 2 pi. So let's go ahead and quickly compute all of these table values for this parametric system. Okay, folks, the table of values is complete. Let's go ahead and plot each of these xy pairs. So the first thing I have is 3, 0. So plot 3, 0. Then I have 2.4, 0.7. 2.4, 0.7 is about right there. And then I have 1, 1, right there. Negative 0.4, 0.7. Right about there. Negative 1, 0. Negative 0.4, negative 0.7. All right there. 1, negative 1 is right here. 2.4, negative 0.7 is about right here. And then if our table had gone to 2 pi, we'd start back over here with 3, 0, 2.4, 0.7, etc. So now that my points are plotted, I can sketch the solution curve through these points and try to kind of give you an idea of what this looks like. It looks like that. That's not too bad. And the one thing I'm missing is the problem said draw arrows on the graph to indicate the direction of the path as t increases. So remember, we started here and we went this way. And then we continued this way, and continued this way, all the way back until we got to the point where we started. So that example problem is done. That's we plotted the graph of that system of parametric equations. Let me go ahead and show you how you would do this on your calculator. So I'm going to go ahead and pull up my TI Inspire, and I'd like to go ahead and graph this system. So let's go to a graph page, and then first thing I need to do is change the graphing mode. So the graphing mode default is always function, but we're going to go down here to parametric, new style of curve that we can graph. So for this, we had our x function was 1 plus 2 times the cosine of t, and our y was just plain old sine of t. Okay, and let's take a look down here. Notice that it says t is going to index from 0 up to 6.28 with a step of 0.13. So again, your calculator is going to plot a bunch of points and then approximate a curve through them. You should recognize this value right here. 6.28 is about 2 pi, and if you need to graph a different type of parametric system, one that doesn't involve trig, you might need to adjust this to be something different to match whatever the application is. So I'm ready to go ahead and grip it and rip it now, and lo and behold, there's our graph. It'd be nice if we could zoom in a little bit here. So let's take a look. There it is. Looks a lot like an ellipse. Foreshadowing. We're going to be talking about ellipses in the coming weeks. Okay, how would you do this on your TI-84? Well, on the 84, you're going to, when you turn your calculator on, you're going to go to the mode button, and you're going to scroll down to a line where you see something like, on an older 84, it says Func, Par, Pol, and Seek. And you want to pick the second option, which is par, stands for parametric. And then when you go to your y equals for entering equations, you're going to see that you have x1 sub t and y1 sub t. So you can enter each of the polar equations just like we did here. Excuse me, parametric equations just like we did here. Okay, let's move on to example number 3. Example 3 says, find the solution equation for the following system. Graph both the parametric system and the solution on your calculator. Are the graphs exactly the same? If not, explain why. Okay, so the first thing I'm going to do here is work on the solution equation. And the one thing that I notice when I look at this is I see that both this equation right here and this equation right here, they both have e to the t. Because they both have e to the t, both x and y have e to the t in them, I'm going to go ahead and solve for e to the t and see what I get. And I'm going to start that by analyzing the function for x. So x equals 2 times e to the t. And if we go ahead and solve for e to the t, we get e to the t equals x over 2. Okay, so now that I know what e to the t is, let's go ahead and analyze the function for y. The function for y is e to the negative 2t, and that's equal to e to the t raised to the negative 2 power. We already know what e to the t is. It's x over 2. So I can substitute x over 2 in here, raise that to the negative 2 power. If you recall properties of exponents, you know that this is the same as 2 over x squared, because a negative exponent means reciprocal. And from there we can simplify and say y equals 4, that's 2 squared, divided by x squared. And that is our solution equation. Okay, so let's go ahead and graph that. I'm going to go ahead and graph that on my TI Inspire. So I'm going to graph the function 4 divided by the quantity x squared. And I get that. Hey, that's a pretty cool graph. Okay, there you have it. That is 4 divided by x squared. And let's see what we were asked to do next. Find the solution equation for the following system. Done. We graphed the solution equation, but I didn't graph the parametric system yet. So let me go ahead and graph the parametric system. I'm going to go ahead and do it on my calculator. So I'm going to go Menu, Graph Entry Edit. I want to go parametric mode now. And my x value is 2 times e to the t. And my y function is e to the negative 2t. And here's, oh, hold on, folks. Back it up. Back it up. I got to get down into the y function. So I got e to the negative 2t. And before I grip it and rip it, I just want to make sure. I'm still struggling, folks. You deserve better. E to the negative 2 times t. There we go. Okay. Double check before I grip it and rip it. Looks like I have that entered correctly. This is going to take t from 0 to 6.28 with a step of 0.13. Well, we need different than that because this says for t goes from negative infinity to positive infinity. So what I'm going to do here is I'm just going to enter a large negative number here. Like let's just go negative 1,000. And then let's go with a large positive number here, like positive 1,000. And this might be a little bit too, let me back off on this a little bit. Let's go 100 to 100. Okay, and this is going to give us, let's see, that's a span of about 200. It's going to give us plenty of points to graph this thing. I'm going to grip it and rip it, see what happens. Okay, so I have graphed it, and what you can't see here is that this parametric equation, I'm going to change the color for you. Turn it to red. The parametric equation is only on the right hand side, so it looks the same as our solution function 4 over x squared, except it's only on the right hand side. That should be a concern to us. That should be a big concern to us. So we have a problem. We better do a little investigating here, folks. I went ahead and copied the image from my calculator over here on the notes page. You may want to graph this just so you have it for reference. And here's the question I have. Question. Why is the parametric system graph only the right-hand side of the solution graph? So again, why when we graph this parametric system do we only get half of this solution equation? Well, here's the answer, folks. Our solution must be wrong. It's actually incomplete. Okay, so I'm stating that our solution is wrong, but it's actually not wrong. It's just incomplete. So how can we complete it? Let's look at the original system. And we're going to look at x equals 2 times e to the t. This x is going to be greater than 0 for all t. Okay, so because x is always going to be positive, we need to restrict the domain on our solution equation. So our solution should be y equals 4 over x squared for x greater than 0. Now that's our solution equation. So scrap what, oh, that didn't go well. So scrap what we had before and write this as our solution. Y equals 4 over x squared. But we got to restrict our domain to x being greater than 0. Now you might ask yourself, Self, why did that happen? Everything we did up above here algebraically was correct. Well, remember, we actually squared something. So when you square something, you can add extraneous solutions to the problem. And that's what happened. We added an entire half of a graph that was an extraneous solution. Okay, folks, that's it for section 11.2, excuse me, 11.10, parametric systems. That's a pretty quick one, and hopefully you're able to whip through WebAssign pretty quickly.